In this session we will discuss intercepts, and this is actually our second method of graphing linear equations. The first being table of values. So again, intercepts will be our second method of graphing linear equations. Now when we're talking about intercepts, basically all we're saying is an intercept is a point where a graph touches an axis. That's all we mean by intercept. It's a point where a graph touches an axis. So real quick, let's say, okay, we have our graph. Alright, well, we have our axis, excuse me. So this will be our x-axis, our y-axis, and we graph a line that looks something like that. Okay, well, the point where this line is touching the y-axis would be known as the y-intercept, and where it's touching the x-axis would be known as the x-intercept. So again, it's just a point where a graph touches either the y-axis, y-intercept, or the x-axis, x-intercept. That's all we mean by intercepts. Okay, so when we're wanting to use this particular method for graphing a linear equation, first thing is we want to get it in what we call standard form. Ax plus by equals c. Alright, again, this is known as standard form. And a couple things we need to know is, first, we want all integer coefficients. Okay, and we want to make sure that x term is positive. Alright, now as far as the x term being positive, I have seen equations put in this form where the x term is not necessarily always made positive, but generally speaking, to put an equation in standard form, we want integer coefficients and we want the x term positive. Okay, so basically what we're saying is, if we're wanting to graph using the intercepts method, we're wanting to get the x and the y on the same side of the equation. Here's our equal sign, right? So we want to get the x and the y on one side, and we want to get our constant term on the other side of the equation. Our constant term being the term that does not have a variable attached to it. So if this is our equal sign splitting our problem in half, on one side of the problem we want our x and our y, and on the other side of the problem we want our constant term. Okay, and in putting an equation in standard form, we have to make sure we have all integer coefficients, so no fractions, no variables for coefficients, and our x term is positive. Alright, so once we've put the equation in standard form, we can now go about finding the intercepts. So let's say we start by finding our x-intercept, so abbreviated is just x-int, x-intercept, and the way we do that is by making y equal to 0 and solve for x. Okay, so we make y equal to 0, solve for x. So why do we say y is 0 for when we find our x-intercept? When we find our x-intercept, we're saying that the graph is touching the x-axis at some point, And anytime you're on the x-axis, your value for y is always 0. So if you notice, if we looked at this point has some x value, but y is 0, because we have not gone up from the origin and we have not gone down from the origin. We're still on the x-axis, and as long as we're on the x-axis, x-intercept, then the value for y will be 0. If I made a point right here, that's an x-intercept, we're on the x-axis, and y is still 0. If I made a point here, on the x-axis, so it's an x-intercept, y is still 0. Anywhere on the x-axis, y is 0. Now, after we find the x-intercept, we can go about finding the y-intercept. And to do that, now we want to make x equal to 0 and solve for y now. Okay, and same point applies. If we're looking at the y-axis, if we see a point on the y-axis like this one was, that's considered a y-intercept. It's touching the y-axis. Well, anytime you're on the y-axis, x is 0. So for this point, y has some value, a positive value, since it's above the origin. It's above the origin. So y would have some kind of positive value, and x would be 0. Because from the origin, we have not moved in the right x direction, which is positive x direction, and we have not moved to the left, which is the negative x direction. We didn't move to the right of the origin, we didn't move to the left of the origin. So x will remain 0. And any point on the y-axis is considered a y-intercept, and for all y-intercepts, the value of x is 0. Okay? Alright. And so once we found both intercepts, then we can simply plot the intercepts and graph. Alright. Plot and graph. Plot the points and graph. Connected lines. That's all we're saying. Plot the points and graph. Okay, so let's look at some examples. Let's go with, to start off, 2x, say a 2x plus 3y equals 6. 2x plus 3y equals 6. Okay, now let's check our steps. First step says get it in the form, standard form, which means x and y need to be on the same side. If you look, you notice x and y are together, constants on the other side of the equal sign. We have it in form, all integer coefficients. So my coefficients being the 2, the 3, and the 6, they're all integers. There aren't any fractions, there aren't any decimals. And my x term is positive. Okay, so these two check out. Alright, so we're good with standard form. So now I can find my x-intercept. So for my x-intercept, I'm going to find x by making y 0. So I rewrite the equation, and where the y was, I make it 0. So if you see 3 times y, now y is 0. So 0 times 3 basically just turns that into 0, so it cancels. So you just have 2x equals 6, x equals 3, because you divide both sides by 2. 6 divided by 2 is 3. So your actual x-intercept would be 3, 0. Alright, so there's your x-intercept. So we've done that. So now we got to find our y-intercept. Y-intercept, to do that, we make x 0, find our y. Okay, so now what I want to do is rewrite my equation, substituting a 0 in for the x. So now 2x, where the x was, I now write 0 plus 3y equals 6. 2 times 0 is 0, so that just basically disappears. And you're left with this, where y equals 2, because divide by 3, 6 divided by 3 is 2. and so you end up with a y-intercept of 0, 2. Now this becomes real easy to graph. Alright, all you would need to do is, let's see here, let's make us a line. Okay, let's make us another line. Okay, and now 3, 0 is our x-intercept. Here's our x-axis, y-axis, 3, 0. So if we're going to say each one of the blocks, each one of the grids is 1, so 3, 0 be over 1, 2, 3, and make a dot. There's 3, 0. 0, 2, up 1, up 2 on the y, because it's a y-intercept. Y-intercept is on the y-axis. X-intercept is on the x-axis. Alright, so have those two. So all I have to do now, connect them, and there you have it. There's my graph right there. Okay, there it is. So that's all it is to it. Let's look at another example. Okay. Alright. So now let's look at one. Let's see. Let's try. Alright. Let's try 4y equals 3x plus 12. Okay. So 4y equals 3x plus 12. And we want to graph this equation using intercepts. First step says get it in the form, so we need the x and the y together. I notice my x is on one side of the equation and my y is on the other, so I need to bring my x over here to my y. So since it's positive 3x, I subtract 3x from both sides. Cancels here. Now these are not like terms, so I cannot combine them, so I just write them out. So negative 3x, there it is, and my y is positive, so I'll say plus 4y. And on the other side of the equal sign, I only have a 12 left because the 3x canceled when I subtract it. So now I have my x and my y together, my constant's on the other side, but my x is negative. And that's a problem because I want my x term to be positive. I need my x term to be positive. So to get my x term positive, I can either multiply or divide everything by a negative 1. Multiply everything by a negative 1 or divide everything by a negative 1. It has the same effect. Basically all it does is changes all the signs. So when that happens, I now have an equation that looks like this. So 3x, negative 3x is now positive, 4y was now negative, 12 is now negative. So here's my equation. I have my form. So I can find my x-intercept by making y 0. Well, if this is a 0, then 0 times 4 would be 0. So all of this right here would cancel, and I'd just be left with the 3x equals the negative 12, where my x would equal a negative 4, and my x-intercept would be negative 4, 0. Okay, because I divide both sides by 3, negative 12 divided by 3 is a negative 4. Now I find my y-intercept. And to find my y-intercept, now I'm going to make x 0. Okay? To find my y-intercept, I make x 0. So I go to my equation. Now x is 0. So if this x is a 0, that's like saying 3 times 0. 3 times 0 is 0. So this whole thing here would disappear, and I'd just be left with a negative 4y equals a negative 12. Divide both sides by negative 4. Y would equal 3, and so my y-intercept would be 0, positive 3. Alright, so if I went to plot those points, negative 4, 0 is my x-intercept, so I go to negative 4 on my x-axis, negative 1, negative 2, negative 3, negative 4. Again, I'm making each hash, each line, a unit. So negative 4, 0 would be right there. There's my x-intercept. Okay. And 0, 3, up 1, up 2, up 3. This is my y-intercept. So that's 0, 3. And I can connect the dots. That's not good. Let me see if I can I move it? No, that didn't work. Try this again. Picking bad points. One more time. There we go. That's better. Alright, so graph it. There we have it. There's our line, the graph of our equation right there. And there you have it, using intercepts to graph. Now we'll do one more just to make sure you're aware of the different issues you can face with graphing using this method. So, matter of fact, let me just go here, erase that, erase that. Okay. Alright. Alright, so now try to see if I can squeeze this in. Probably should write it on the other side, but we'll figure it out. Here we go. So last equation I want to do with you would be y equals 2 over 7 x minus 2. Alright, if you know anything about slope-intercept form, this equation currently is in slope-intercept form, and we want to get it into standard form. And one of the issues with standard form is that we have all integer coefficients. Well, currently I'm faced with a fraction as a coefficient for my x term. So to get rid of the fraction, I multiply all of the terms in the equation by 7, by the common denominator. So if I multiply everything by 7, I then have 7y equals, now when I say 7 times 2, that would give me 14, and then 14 divided by this 7 right here would give me 2, so 2x, and then 7 times that would be a negative 14. Okay, now I'll go sideways with it. Now I need to get my x over here with my y, so I subtract 2x from both sides. If I subtracted 2x from both sides, I'd end up with negative 2x plus 7y equals a negative 14. Okay, so I'm saying I would go there next, and then from there I don't want a negative for my x term. Remember, my x term has to be positive. X term has to be positive. So I'd multiply everything or divide everything by a negative 1 to get rid of this negative on my x term. And so that would give me 2x minus 7y equals 14. 2x is now positive, 7y has become negative, and the 14 has become positive. So I changed all my signs. Now I'm ready to take this as my equation in standard form. To find the x-intercept, I make y 0. Okay, so that would give me 2x equals 14. X would equal 7, so 7, 0. And to find my y-intercept, I have to make x equal 0. X would be 0, so if x is 0, I end up with a negative 7y equals 14. And in that case, y would be a negative 2. So 0, negative 2 would be my y-intercept. Make sure I have enough space to graph. 1, 2, 3, 4, 5, 6, 7. So let me just do this. Let me move my y-axis over. Okay. Move my y-axis over to right here. So this is my y-axis. So 7, 0, 7, 0 is my x-intercept. So 7. So that's from the origin. I count 1, 2, 3, 4, 5, 6, 7. So there's my 7, 0. Alright, my x-intercept, and my y-intercept is 0, negative 2. So from the origin, count down 1, 2. So there's my 0, 0, negative 2, my y-intercept. Connect to graph. Hopefully I can get it right this time. That should be halfway decent. Okay. And there you have it. There's your graph of this equation using the intercepts method. Alright. So again, this is our second method. The first method we talked about was table of values. So table of values was our first method of graphing linear equations. This is our second method. Intercepts is our second method of graphing linear equations, and this method is typically used if the problem is presented to you where x and y are already on the same side, and preferably if the x and y terms divide evenly into the constant term. And if you're asked by chance for both intercepts, if you're asked to give both intercepts for the graph, then this is definitely the way you'd want to go, because this is the only method that is designed to give you both intercepts without necessarily having to graph the equation. Just by solving for the working through the steps to solve for the intercepts, you would find out what they were without having to actually do the graph of the equation. You would know what the two intercepts were. So if you ever ask for both intercepts, this would be the method to use. At this time, we will conclude this session.